So, hello everyone. Welcome to this week's episode of ClueCon Weekly. This week with us, we have Ildikó from the Open Infrastructure Foundation. And thank you for joining us. It's a great pleasure to meet you.
Thank you for having me. I'm very excited.
So you might not know what the Open Infrastructure Foundation is, but OpenStack probably rings a bell. But I'll let Ildikó introduce herself and then let us know what they're doing at the foundation.
Sure thing. So my name is Ildikó. I work as Senior Manager of Community and Ecosystem at the Open Infrastructure Foundation. And as Luca mentioned, this is the foundation that supports OpenStack, which is an open source cloud platform. So from there, it kind of probably makes more sense when I say that the Open Infrastructure Foundation is a nonprofit organization, and we are supporting open source software development communities. And as our name suggests, most of our communities are really focusing on the infrastructure space and more on the infrastructure software space. So if you look at like a full stack deployment, then you obviously have a hardware layer, and then you have operating system and all other components of the infrastructure as a service layer type of components. And then you get, the platforms, application management and orchestration and all those kind of components on top. So most of our projects are on that infrastructure as a service layer, as I like to call it. I think that kind of puts it into perspective. So most of our projects are running either on the hardware or like really close to the hardware. Usually there is an operating system layer between, most often Linux, or in other cases Windows or other operating systems as well. So that's what we are doing. I am personally a big open source advocate and evangelist. I really do think that collaboration and working together on common problems is the future. And if you all look at how the software development space looks like, for instance, in more enterprise software side of things, then it really is a good and common practice to use a lot of open source projects and components in deployments worldwide. So I think a great example is the Linux kernel. It's on Mars and it's open source, so it must work. I think that is a great proof point. And if you look at OpenStack, for instance, which is another huge open source project, we just celebrated its 10-year anniversary not that long ago. So it's been around for a decade now, and it came out as a collaboration between NASA and Rackspace. And since then, it grew tremendously. So we have, I think, over 70 public clouds around the globe, and a lot of private cloud deployments in various spaces like scientific research. I always love to mention CERN, because who doesn't like a large hadron collider? And CERN is running a lot of workloads on top of OpenStack. They have a large installation, and with that, they aren't just running those workloads on OpenStack, but they are also very active contributors to the community. So they really are a great example in terms of how open source works and what you can get out of it. And OpenStack is used in many other industry segments, like telecommunication is a big one, for instance, but you could mention retail, finance, and the opportunities are endless, I would say. And this is also how our foundation came to life. So we have been supporting the open source community. And in the past couple of years, we started to also expand a little bit. So we have a couple more projects now, and not just OpenStack. And we are also taking on new projects. So if anyone in the audience has an infrastructure project that you are planning to open source or create in the open source space and looking for someone to help you, then we are definitely here for you and the community as well. So if anyone is interested in the projects and wanting to find links, our website is openinfra.dev. So all the magic information is linked from there. And if not, let me know. And we will fix that.
Yeah. Well, OpenStack is probably one of the most popular open source projects in the world. I think it's third or fourth most active, something like that. I think it's yeah, and even Chromium is debatable. Like I know Chromium is ahead in terms of contributions, but Chromium has Google backing them, and OpenStack doesn't. So before we go into a couple, so I have two trails I will like to take the interview on. One is very technical, so I'd like to understand more about what the other projects are, mostly because I'm a software architect and I'm always playing with new things. The other thing is more community and project sustainability based discussion, which has been very interesting. We've taken this angle in the past on CCW, the idea that there are a lot of large companies who use open source projects and don't give back. And in some cases, their entire product is one of our projects, just with a brand on top and running on their own cloud. And that so let's start from that first. How do you balance that with the foundation? Like I assume the foundation's idea is to make the project sustainable. But how did you start with that? Because there are many projects, as you know, including largish ones, like that struggle with maintaining an open source identity and getting continuous patches and contributions. There's volunteers, but as you know, well, it's not OpenStack cases, but in most cases, medium-sized open source projects, they have like 5 or 6 maintainers, tops, who do most of the work. And those people usually have jobs that they need to do to actually eat. So that's how do you balance open source with business, and how does a foundation help?
Whew, how many hours do we have for this interview?
We can do another segment if you like, but yeah, let's do the short version first.
Okay, I mean, this is a really wide
Fancy.
scope question. Okay, let me put myself together to give you the shorter answer to that one. So when it comes to a foundation like ours, what we do is we provide services, and services include community management that covers a lot of what you were talking about. And there is also some program management, trademark kind of things, as well as marketing. I just dropped in the dirty word, right? However, when I say marketing, it's usually more about raising awareness about the project, users, what people are doing with a project. So it's really more about sharing as much information as we can. And when it comes to the word marketing, it really is more about the format of how that information gets shared. So these are just a few areas to highlight where we support our communities. And when it comes to things like sustainability, as you say, diversity, activity of a project, that falls under community management a lot. A lot of part of it does. And I am personally really active in the community management area within the foundation. I am the community manager for one of our projects. It's called StarlingX. We can talk about that in the more tech part. But when it comes to the community management part of it, it really is a lot about education and also teaching and letting people know about what open source really is all about. Our foundation and our communities are following a set of guiding principles. We call them the 4 opens. They are, open community, open design, open development, and open source. And as you can see, open source is only one of those 4 opens. That is, let's say, by now the most trivial one, which say that the source code and the artifacts are openly available under an open source license, which is an OSI compatible license in our case. And that is the trivial one. I put the code out there, it is openly accessible, so I'm done, right? I'm doing open source. So if you just really take the term and say open source, that's what a lot of people are associating to. That is where open source stops. However, that really is where it all starts, and that is just one thin layer. And the open design, development, and community is what really open source is about, because that's where that sustainability comes in. That's where that open collaboration comes in. And those are really the components that make collaboration possible between, individuals who are interested in that technology and solution, companies and organizations of various sizes who are sharing the same problems, are trying to find a solution together. And the infrastructure space is a really great example, because in most cases you're not making the big money on the infrastructure software components, but really on the applications that go on top and any other secret sauce in there. But there are a lot of components that everybody needs, and nobody's really making the big money on that one. So it makes a lot of sense to start collaborating on those components and really just lower the maintenance cost by working together. And at the same time, surprisingly, probably for many of the people who are listening to this or watching this interview, is that innovation is also faster if you're
Oh yeah.
working together, because you have access to so many talented people with a lot of experience around the globe. So not just within your company, but there are people around the globe who have different viewpoints, different experience, and they can bring so much to the table. And once you have access to all that information, everything just goes so much faster, and so many more eyes on the code. So actually, open source code,
Yeah.
I think, in active communities, in my personal opinion, is usually more secure and more stable, because you get so many more people to review it. And this really is the ideal of open source, that we are working on something for the common good that we all need. We want to solve it together. And by doing it together, it also gets that much better, as opposed to, the proprietary software development, where well, you never really know what happens behind closed doors and what's in that
Mhm.
black box, as what you get when you purchase something. So that is um, that is what the Four Opens is all about. And what we as a foundation do, we really are there to teach, educate, coach, and mentor, which is, well, most cases is really needed. And you really just have to give time to people to understand what open source really is all about, and how they can do it well. And again, CERN is a brilliant example in terms of using the
Yeah.
software and giving back and contributing. And when it comes to contribution, it's not just code contribution, but it really is anything that anyone can possibly do. Give feedback,
Content.
report a bug, fix a typo in the documentation, or even more importantly, if you see something that's missing or not written correctly, or in a clear way, then go in and you can fix that. People can even help out with marketing, like write a blog post, speak at a conference, or take an interview like this. And talk about the projects where you're involved, or the projects that you're using, how it's working out for you. Really, everything counts as a contribution, I would say, because all those components are really important for the community and the success of that community and that project. And I could ramble for a few more hours on this.
Yeah, sometimes it feels, yeah, all of that is very important. Sometimes I feel like what's struggling is, again, the mid-sized open source projects, because the one man band small things are usually just one library that does one specific things with images and JavaScript, whatever. Once it works, it doesn't require much. The middle-sized projects, in my opinion, are the ones that suffer the most when companies use them without any giving back. Because again, OpenStack is big enough that the security and the improvement aspect of such a large community cannot be understated. Like that's literally how it works. Like if 1,000 people are using the same thing the moment it goes out, if 1,000,000 people are using it, they will find a bug almost instantly. Like what? It doesn't take time. It's almost too fast. The smaller projects are a different thing, and unfortunately, many of those have large companies that do use them a lot and don't really help very much. So I guess that comes with it. Like you accept the compromise when it's open source. Like sometimes it will happen and you can't really do much because what can you do? I mean, I know people who were given a cease and desist letter just for mentioning their platform was being used by a very famous e-commerce company, a large one, sort of doesn't come from Brazil, but the name sounds like it. And and they got, because the point there was that they were exposing a security information thing. Like if you say we're using that platform, it means that people now know and can try and hack it. But I feels like that's, I mean, the minimum someone like that could do is at least let you, after asking, of course, let you say that it's being used. That would be greatly helped. Like, hey, our platform is used by fictional e-commerce company named after a forest. The I don't want to get another cease and desist letter because I got one, so not from them though. And that's the thing. It's I don't know. It's a compromise we have to accept at this point. I don't think there's a solution. Like if they won't help you, they won't help you. They say they were not not going to contribute patches. What can you do?
I mean,
It's
there is always, again, that education factor, and you usually only have to find one or two allies and champions within a company who start to implement a change, and then eventually that change will start to grow. So I don't like giving up on this, because if you don't succeed one day, then you might succeed tomorrow, the day after, next week, or next month. It's never too late, really, because I think conceptually it's also it is also a bit about, in my opinion, the success of, and longevity of humanity around the world. We have to be able to collaborate on not just infrastructure software, but so many other things. So it really is about the mindset as well. And that mindset eventually has to change if we want to survive on this planet. And open source is really great because it gives people access to those things that we are desperately relying on a daily basis, because at least in the modern world, we are all relying on technology, and we are also trying to rely on technology for, saving the world from ourselves sometimes, like how we are using resources, what happens with, pollution, global warming, and all those kind of things. We will not be able to solve that in silos. And that's the same concept that what open source is built on. And the access that open source gives to critical software components, and these days hardware design, and all other components that people and humanity needs, really, I think that is crucial. And at some point, hopefully, more people will understand that.
Yeah, I think that's a good point. So going back to some technical stuff, I see there are a lot of projects under the OpenInfra umbrella. I'm especially interested in one, which is StarlingX. But if you could give us a quick overview of what other things the OpenInfra Foundation is currently doing, that would be great.
I can do a really quick rundown of our current confirmed projects. So if someone goes at the openinfra.dev website and clicks on projects, then you will see a list there. I think the first one on the list is Airship. It is a deployment and lifecycle management tool. What you really need to know about it is it leverages container technologies, and it deploys, for instance, OpenStack in containers for you. And it uses a declarative way of defining your infrastructure and deploying it. And some of that concept is also implemented in StarlingX. I will get to that one. in just a bit. You will find Kata containers in that list. It is a container runtime. It is actually a really interesting one, in my opinion, because it kind of creates a fusion between virtualization and containers. So it puts a container into a really lightweight, stripped down virtual machine. And with that, it gives isolation. It gives you the option to choose your kernel for your container, every single one of them on the host, and you don't have to depend on the host kernel. And when we talk about things like security, I think it really is crucial that it really actually gives you isolation. So if the host is compromised, your container doesn't have to be compromised just yet. So it is much more secure than traditional containers, which are, as one of my colleagues like to say, they are not really good at containing, which is kind of ironically funny, I think. So that is something that Kata Containers is set out to solve. And when it comes to performance side and how this whole little package behaves, it really looks like from the outside just like any other container runtime, and on the performance side, it also delivers the same or very similar values. So it's a really interesting and great project. So anyone who's playing with, for instance, edge computing use cases, I would really recommend to try it out, especially because of the security related aspects of it.
That's me. That's
Yeah.
that's what I've been doing recently. So that's gonna be super useful for. So yeah, I like the high level isolation. Like looks like each container is really its own operating system, etc. It could. You're right. In edge computing situations, you're dealing with weird heterogeneous platforms where everybody's trying to run a million processes and on the same
Yeah.
instance, and they're all different and they don't like each other for the most part. So isolation would be a very very good starting point. Yeah.
Yeah, exactly. And again, like edge computing use cases, well, one of my focus areas is edge. So I could talk about that for a long time too. But really is like a lot of edge use cases have edge sites that are in remote locations or just really a large number of them. So being able to go out to the place and fix every one of them because of security issues, it's just not good and not sustainable for anyone. So really the point is to try to make that edge site as secure as possible, and Kata containers can really contribute to that. And also working with telcos as well, like a lot of them are using OpenStack, and when it comes to work bits and pieces of the workloads are not liking each other, and when it comes to multi-tenancy, then telcos really are in the forefront of, yes, we have tenants there who just really don't really want to be close to each other and don't like each other, and they really need strict isolation for those workloads for the different clients that are still running on the same host. So it is definitely something that is really important to many, many industry segments. Okay, so that was Kata containers and container runtime. We did talk about OpenStack enough. I don't think I need to really introduce OpenStack. I will just repeat myself that it is a large open source cloud platform. It is a modular architecture, so you can pick bits and pieces that you need for your infrastructure, deploy them, and build your own cloud. Let that be public, private, hybrid, whichever type you prefer. So that's OpenStack. What else we have there? We do have StarlingX. It is an open source edge cloud platform. So the platform is really fine-tuned for edge and IoT use cases and requirements. So the community is looking a lot into things like security, performance, supporting real-time workloads, for instance. If you think about a factory floor and those robots, the real-time aspect really kicks in there. Or even if you think about 5G, there is some timing and real-time aspects there to attend to. StarlingX creates a fusion between OpenStack and Kubernetes, and that is where it's using components and concepts from Airship. So StarlingX is using container technologies to make the platform as flexible and manageable as possible, and it deploys all infrastructure services in containers for you. This also means that StarlingX can treat container and virtual machine workloads both as first-class citizens. You have the option to have a containerized or container-only edge site, or you can also run virtual machines there. One of the more edge-specific features of the platform is called distributed cloud architecture, and that means that it deploys control services on edge sites as well. So the edge sites do have autonomy. So if there's a connection loss between the edge and the regional or central cloud, then the edge site is still mostly fully operational, and the system will synchronize again once the connection is built back up. So the edge sites are kind of mini clouds in a distributed architecture, and then you have the central cloud with a single pane of glass dashboard, and you can perform all kinds of orchestration and automation type of actions from the central side. Like if you have to, for instance, install a patch, then by the push of a few buttons, it will happen on all edge sites. And we do have a really short demo on the starlingx.io website. If people stumble in there, that, for instance, shows how patching works on a larger scale, which is really cool, I think. So that is what StarlingX does. It gives you the platform to just put your application on top if you're building a solution, an infrastructure solution for your edge use case. And we do have Zool on the website as well. Zool is a CI/CD project, and if you are familiar with how OpenStack works on the community and development side, then Zool is actually a project that was started within the OpenStack community, but now it is a standalone project, as a lot of organizations are using just that one project in some areas. And Zool is the project that the OpenStack community is using to test every single patch and change that gets proposed to OpenStack. So Zool is that platform that grabs the change and applies it, deploys an OpenStack cloud, and runs tests on it. It runs both unit tests, and it also runs the full-blown integration test and functional test, as well as upgrade testing. And OpenStack, the community is really proud of the concept of humans actually can't really merge anything into the OpenStack code base. So what humans can do is approve a patch, and once a patch is approved, it is usually always approved when the first set of tests are all green and all succeeded. And once people approve the patch, they say that, okay, it's good to go, it should be merged now. There will be a second set of test suits run on that patch, and once that second set of tests are also all green and succeeded, that's when the patch gets merged automatically. But just because the human said that this code should be on that branch, it will not be there if the tests are not successful. So that is what Zool does to you. It provides you that gating functionality and ensures that no faulty, untested code makes it into the code base. And it's even the same for documentation. All the documentation builds and checks need to be succeeded before a patch gets merged, just to make sure that we are not breaking anything that already is there and works and displays as well. So that's what Zool does in a nutshell. It puts the
more people should use it. Just saying that.
to say the least. It is really popular, for instance, in automotive companies. Volvo, BMW, and others are using that project, for
Yeah, I
instance.
could see that happening. They have so automotive is different than airplanes and all this stuff, because once you deploy something to the systems, updating them requires your car to go back to the shop. In most cases, I mean, unless it's Tesla, or remote updates are probably coming for other cars pretty soon too. But for now, if you deploy something that's wrong to a BMW, now all of those have the problem. And
I know, and it's sometimes it's super annoying. My dad did have a car that I will not mention uh, the brand of, uh, but you can see the car in Top Gear, for instance, and it once won a competition, and no one really expected that the car will last. Nice British one. Anyway, so the fun part of it was I truly did hate that car because it always had issues, and I kid you not, most of the time it was a software issue, a sensor issue, but mechanically there was nothing wrong with the car, but it wasn't
yeah,
going anywhere. And again, mechanically it was sound, no problems there. So when it comes to, applying faulty patches to a car, yeah, please don't do that, because
yeah,
if
I
the
could
car
see
doesn't
how a
want you, yeah,
more
seriously.
strict review process really helps there, because again, you can't really, I could see that being even more critical in something like, I don't know, NASA, space exploration in general, space probe. You can't really sort of patch a space probe once it's launched. It's hard. It's a few
Yeah,
million kilometers away, and finding you forgot a comma in your code is a bit late. So it's
yeah, you really need to test everything. And when you think about the autonomous vehicles that are getting out on the road as well, it's not just the car may not be
mm,
going anywhere because of a faulty sensor, but what if the issue is causing safety problems, and then we are talking about human lives there, and that's
oops, that was an old
that's more
lady.
serious. Yeah.
Oops.
Yeah,
Well, we'll
exactly.
just patch it, no problem. We'll just patch it to avoid old ladies in the future. But for now, that old lady, well,
Yeah, exactly.
not
So
doing so well.
no.
Yeah, it is. You're right. I mean, autonomous driving is very real, and it's going to be so. The number of cars that are going to be around, I don't know when, but I postulate. So, as you know, most of Europe is going to stop selling gasoline cars by 2035. That's probably going to give a big push to electric cars, and probably autonomous driving is going to piggyback on that, right? When the millions start pouring into the automotive industry because we have to buy those cars, there's no choice. Automotive is autonomous driving is probably going to come right after, because honestly, it's just a matter of how much money the world puts into it before it's fixed. At some point, there will be millions of autonomous driving cars going out there, and they will have some remote updating capability for sure. But I'd rather people agree on a patch before it gets rolled out. Yeah, definitely. Yeah.
I know. I think in the US there are quite a few cars that do have some ability to autonomous driving, and yeah, they are already getting tested out on the roads. So you really do want to make sure that the software development part of it is where most of the testing happens first.
I feel like a lot of that is going to involve open source. In my mind, it might not happen, but open source will be the best way to ensure things are correctly vetted and don't have any backdoors and stuff. Because being able to conveniently disable the railway crossing sensor for a car that you for a person you don't really like it would be useful, but that's something you really don't want people to be able to do, right? It's
Yeah, yeah,
oops, the
really.
train was going through. Sorry.
I Yeah, that would be really bad.
Yeah, so
Um,
I think that's going to be a discussion that we need to have, because again, you brought in a very good topic. That's probably going to be the largest high tech rollout in history, and the most impactful, because honestly, even in smartphones, like worst thing that can happen with a smartphone is you find out it has a large security flaw and people can listen to your calls or take photos with your camera without you knowing, whatever. That will be super, I mean, super dangerous, super problematic. It's happened in the past, etc. But in the end, no one directly dies as a result of that. While the old lady likes to cross the road every day at 8 a.m. to go buy some bread, and she'd like to keep doing that for a long time. And we don't want that to stop happening. So that's really true. It's going to be something we need to address at some point.
Yeah, exactly. And just the same thing with work environments, like the factory floors. They are a lot of automation happening there, but there are a lot of large machines, and humans are still, performing their jobs on the factory floor as well, and it can get really dangerous also. So there are so many examples there that really is boiling down to safety of humans. Or there's the healthcare industry, and I
All
think that
right, yeah.
they are, they do have a lot of devices, and more and more things are being used for surgeries as well. So it's not just the imaging and detection, but also the robotic arms that they are now using for surgeries, and those kind of things. So there is a lot of automation happening all around the globe, and when it comes to the safety and security of those, that is also should be a top priority for everyone.
Yeah, that's going to be very very important. Again, I hope there's some open source involvement there, because really there's some stuff that should be really vetted by a community. It's hard to balance that with security, but then I mean, there's if I still think that all things being equal, if a community finds a bug, even if it's critical, it's still better than closed source having the same bug and nobody knowing but the black hat hacker that found it. That's the and maybe they can exploit that for a month before someone notices. It's happened multiple times, like
Yeah, yeah. I mean,
even recently.
so for people who just don't trust what happens in open source communities, like communities like OpenStack, and I think all our communities do have vulnerability management processes. So we like, and our foundation does help the communities with setting these processes up. So this is part of the services that we provide, to help them to make sure that they do have a process and it's efficient, and it kind of goes well with all kinds of regulations and all that. So the vulnerability management, they usually do have a process to report security bugs, in to a smaller group first, so people can observe and figure out how to fix the bug, and then they also have a process to, when to release what the bug is and the solution, and again give that opportunity to the larger community to also make sure that everything is fixed there and tested, and that the security breach is all gone. So there are processes there. So it's not like someone just throws that in, that, oh, by the way, there's a huge security issue here, and now everybody knows where to hack the software the next day. So there are processes there too.
Yeah, the main thing, as someone who's used a lot of cryptography in their line of work, I was part of a ZRTP working group. We've done a lot of work on encrypted communications. I will never use a cryptography algorithm that was an open source. Like that would be literally the first thing I will never do. Like that has to be validated. I feel like more software should be open source just because of that. It's
Mhm.
I honestly hardly trust closed source software unless it's trivial stuff or whatever. But for example, I run a firewall interceptor kind of thing on my computer, so I know what any of my applications running on my computer are doing. So that's
Mhm.
and sometimes you find out weird things like something randomly calling out to Google or whatever. Then you go look at it and it's something like, trying to use GCF or whatever.
Yeah.
But still, why is this calling out to Google domain? It has nothing to do with Google. And from that stems a lot of it. Well, people tend to from outside the business, there's a lot of people thinking that closed source is better. Like, this is a large company, they're going to give me a very good product. It's because they compare that to cars. You will buy a car from a reputable maker. You wouldn't buy a car from someone who looks like it's a few people who are just soldering together parts in a garage. Turns out those people are better at it than the guys making the actual car. But
yeah. And also, like that starting point that I was talking about at the beginning of the interview of open source being that first step. I mean the source code being available at the same time, because the source code is available for everyone. You can download it, you can deploy it, you can run whatever tests that you would like to run on it. You can try to hack it, and if you can, then you also have a chance to dig into the code and go fix it. So how can this get any better? Because when you get a proprietary solution, you can't even open that box. Most often you don't know what's in that black box. So even if something goes wrong, like, I'm not even talking about security issues, but just talk about functionality, that you expected something to work in a different way, you're fully reliant on that one vendor to fix it, and they will either fix it or they will not fully fix it. Maybe they will ask you, to pay extra to get that fixed because
randomly not working. Yeah,
that's not what we agreed on. We delivered what we agreed on, and then you're just you're fully dependent on the vendor with closed source software and those black box solutions, and they might work well for a subset of what you want, and then the rest you're in their hands completely, and you can't do anything else. And usually by the time someone realizes that it's not exactly working as I wanted, they are locked in. So vendor lock-in is reality still. That's how a lot of business cases are working, that someone deploys the solution so widely that it's so costly to switch over to something else that they are just stuck with the vendor that they don't really like anymore, but it's just really expensive to move over to something else.
Yeah,
So,
there's a lot there that needs to be worked on. But still, I think open source is now part of the world, is not going away. If anything, we need to expand the reach, like make more companies out make their stuff open source and whatnot. I mean, of course, some stacks will always stay closed source because that's literally what the company does. But in many other cases, open sourcing is the important part. It's really, really useful. Well, I mean, we're nearing the end of our time. So, well, thank you so much for joining us. It was a huge conversation. We talk about so many points and so many things. We should probably do another segment soon just to go forward with some of the reasonings we've been doing.
Yeah, I thank you for having me. I really enjoyed this conversation, and honestly, I think we were just kind of scratching the top of the iceberg here with most of the topics, because there's so much more to uncover and talk about. So would be happy to join again.
We'll do a part 2 very soon. Or maybe you could come join us at ClueCon, which is going to be our conference in October in Chicago. And sign-ups are still open if anybody wants to take a look. I'll be doing the FreeSwitch training at the end of the conference too. So if anybody wants to learn about FreeSwitch, it's going to be me. And look up ClueCon.org or ClueCon.com, really. Cool. And thank you, Ildikó, for joining us today. I hope I didn't get your name too wrong. So
you're good.
And other than that, thank you so much for joining us today. And it was a pleasure talking to you.
Thank you. And have a good day, everyone.
And for the rest of the people, I'll see you next week. Goodbye.